We have Dhruv Patak from Go Ibibo, who is going to talk about scaling in Go Ibibo.
So hello everyone, I'm Dhruv. I am Director of Engineering at Go Ibibo. So let's start. So as you can see, this is a NumPy matrix, right? Well, actually it's not a NumPy matrix, it's our auditorium. So can all of you please just stand up once? Stretch yourselves and introduce yourselves to index -1 and +1 in horizontal rows to the person to your left and right. In case you already know them, that's cool. Thank you, please be seated. So now everybody is energized, we can start. So we have our apps on all the platforms, desktop as well as mobile. And just to give you a glimpse of our scale, we have 30 million raw requests per day. So by raw, I mean which are not offloaded by our CDNs, the Akamai layer that we have. We are #1 hotel booking engine in India and #2 in flights. And we have 20 million app downloads. And more than 75% of our transactions and traffic comes from mobile. So we were not this big from the very beginning. So eventually we had to scale to support our traffic and our business. So initial stack was a simple Python stack running on mod Python and Apache. So because it was monolithic, it has problems of its own. You can't decouple apps. One app of one performance affects the other. Developer onboarding is hard. So we eventually moved to service-oriented architecture. So this is how the architecture, is the text visible to the people at the back? Okay, I'll share the slides so you can see the diagrams. So we moved to service-oriented architecture where each component has its own fine-tuned components as well as the architecture, and the APIs, the services talk through APIs and message queues. So I'll give you examples of domain-specific components. So one component is Voyager. It was one of our initial attempts to go towards the service-oriented architectures. And what Voyager does is it's a graph-based querying system. It powers a lot of content, searches, all the static data on apps as well as websites. Okay. Okay, I'll move forward to the diagram-based slides. And there is Ingo Ibibo, which is a seller-facing app based on transactions and finance APIs. So it runs on Django and MySQL. Then there is Hermes, which serves dynamic APIs. It fetches static data from one endpoint and pricing data from one endpoint. It has to be very dynamic and scalable. So it runs, earlier it used to run on Python plus G event. Now it runs on Golang. And we love open source. These are the open source tools that we use. So if you have any questions regarding any open source tool, you can come to our booth or contact me after the talk. So let's focus on Voyager. So why we named it Voyager? So Voyager is the farthest man-made object from Earth. Voyager means travel, voyage means travel, Voyager means someone who is traveling. And this yellow dot that you see, that's Earth. So Earth is not visible. The convention center would not be visible, obviously. And second, Voyager is the platform that we use for all our querying and our static data. So this is the base of Voyager. So it's a graph-based system. The graph has been designed in MongoDB, not in Neo4j. I'll share the reasons with you when we move on to the scalability part. So this is a small snapshot of more than 10 million nodes that we have. So India is a node. It has children. It has further children based on geographical and administrative hierarchy. Then everything like travel OTA needs, airports, hotels, places I can visit, relationship between what airlines flies to which place, what bus connects which stations, how railway moves from one node to another. So every modeling is done on this graph. So in case you want to query any complex thing, so if I visit Alsur, my flight is to Bangalore, and if I go to Alsur, what are the places I can visit? So the graph can tell you if you go to Alsur, you'll take Bangalore flight because Bangalore is the city parent. And in Alsur, you can go to Alsur Lake and you can book ITC hotel. So this is actual graph from New Relic, the tool that we use for monitoring. So we receive around 16 million requests per day. That amounts to around 20K requests a minute. And we are constantly under 20 millisecond in response time. And that's not plain querying. We are not doing straight do query and serve response. These are very complex queries as I showed you in the previous graph. And this is a service map, again from New Relic. It shows two things, how loaded Voyager is and how our service maps are connected. So as I said, we move to service-based architecture. So all the components here are other services that we use, and at the center is Voyager, and on the other side are the components that Voyager uses at its backend. And I showed you the open source tools used at Go Ibibo. These are the open source tools used for Voyager. So for search, we use Solar with PY Solar, and Python is involved everywhere, of course. We use Amazon Web Services, we use New Relic, we use Celery, we use Kafka, we use HBase. And this is how our current component Voyager is designed. So it's based on Voyager, but it doesn't, since it has to be an all-rounder, it serves static content, web pages as well, and it has a very high throughput API framework as well. So we don't have the ORM, the MySQL part. We have custom written MongoDB wrappers and a custom written API framework. They query the ORM or the Python classes or the Solar layers and serve content. And at the backend, it's Nginx plus UWLGI as the server layer. So I'll share a few learnings that we did while scaling. So for our caching, we don't use memcache now. So we did a comparison between memcache and Redis and discarded memcache completely. So reason for that was memcache has slabbing problems. It has a slab size, and your API payloads might be sometimes more than 1 MB, the default limit that it has. And in case you try to change your config and increase your memcache limit to, let's say, 5 MB block size, you'll start having fragmentation problems, because memcache creates slabs in power of 1.25. So you'll be wasting a lot of RAM. And with Redis 3.0, there is nothing that Redis cannot do, apart from added functionalities that Redis provides, that memcache does. So if you have both Redis and memcache in your stack, so what memcache will do is it will provide you a better memory footprint for plain caching. But even if you discard memcache, your stack will work just fine. And for graph as well, as I showed you the graph, we initially started using Neo4j. Its graph querying language was rich, but the other requirements that we had were not good. So it is not a very good NoSQL store. Its geospatial searching thing was very weak. And so what we did was we tried to emulate the graph in MongoDB. It is a cyclic graph, and each node has the parents of all the ancestors that are involved. So within just one query, you get the whole chain till the very root, which is the world. And we benchmark and optimize all the times by changing small components in our API. So in New Relic, if we see a JSON serialization is taking a lot of time, and if we already know the payload type, so we compare maybe simple JSON, we change to UJSON. So Ultra JSON is a highly efficient C-based library, which can be used as in-place replacement of JSON, but it will have some sacrifices over some certain custom data types. But still, if you know the payload type, you can use Ultra JSON. And for our SEO thing, we pre-cache a lot of things. So for a fresh API call, even if it's doing complex querying, it is fast. But our SEO pages and certain expensive APIs are a combination of many complex operations. So what we do is we have Celery tasks running millions of tasks a day, which pre-cache and pre-compute a lot of data. And with pre-caching and pre-computing comes invalidations, so that you don't cache your data for more than the TTL, and a consumer might be getting incorrect data. So we use Kafka queues for invalidation of data. Optimize your data sources. That's it. Use right data types, use integers. When you can don't use varchar with an incorrect length. Compress when you can, but don't compress small objects, because the compressed object might be bigger than the uncompressed one, and you will be wasting CPU cycles as well. For monitor extensively, we use statsd and New Relic and Sentry, and log expressively. Use correct logging levels. Don't choke your servers with GBs of data in debug. Use correct informations level info debug for correct purposes, and then aggregate them and use them judiciously and analyze. So as Voyager is a high throughput system, I'll show you some examples where it is being used and how Python is powering certain components, certain end user features. So this is example of our search, and if you compare all other OTAs, our search is better than any other OTA, if you'll see. So a user is searching for Ghaziabad with a wrong spelling, and because of the graph that we have, we aggregate data have our ranking algorithms, and now we can suggest Delhi airport. You won't be able to see the distance, but there's distance and ranking criteria available for all the airports. You can try this right now on your Android app, Ibibo app if you have. Then for recommendation systems, we have collaborative, since sometimes some certain hotels are sold out, we suggest very similar hotels with weightage based on similarity, price similarity, and collaborative filtering, past user behavior on both the hotels. So we use NumPy and Skippy for those things. Sometimes we used to do data simulations. So we have a feature called Go Contacts, where once you are connected to Go Ibibo app and you import your phone book, all of your, when any of your contact books, you will get 50 rupees Go Cash. So we had to do simulations that how the system will run and how much money we might be burning in these distributions. So for that also we use NumPy and Skippy to generate triangular distributions and to see probability of how each of the transaction will happen. Now if you open Google and search for hotels in any XYZ city, you'll see that Go Ibibo is at the top. So content is one reason for being on the top. There are obviously 200 and more than 300 factors for a good SEO. So, but one of the very big factors is how healthy your system is. So once a crawler comes, it has to crawl millions of pages in a queue. And if each of your page is, taking a lot of time, so the crawler assumes that the page is slow and it will be affecting the user behavior as well. And the crawler will penalize you. So you'll never see a slow site which is in the top 10. So what we have is, we have millions of pages, but we have 0% error rate and very fast crawling rate. So this gives us top positions in hotels and flights SEO and other travel SEO if you search. And since Voyager is serving loads of systems, it has to have a very agile build framework. So for Voyager, we don't have any manual QC or manual effort in any intermediary stage. If you make a commit and push it to merge it with master, and then you push a tag, you will have the same code running in production within 5 minutes. So we use Jenkins for our build system. Once you push a tag, we do 3-4 steps of testing. One is p-violent. So p-violent is very strict. It makes you feel like a retarded coder. So what we do, we use test only for a subset of p-violent errors, not for everything. Then we use Django nodes for our unit testing. So each of the API method or pages that we have is tested using Django nodes. And after Django nodes, we see the coverage. Coverage is not used as a blocker. It is used for our study that our test cases are covering most of our code. And if you are able to see, we send multiple releases a day, maybe 6 or 7 releases a day. And even when the release is deployed, we have 0% downtime. So this is how the flow works. So 0% downtime comes because, so once your Python code has passed all the 3 stages, it gets deployed. So Nginx plus UWGI supports multiple upstreams. So Nginx confess multiple upstreams. So you have one upstream as the one which is running on production and second one as the backup. So what deployment script does is, it switches the position, it loads the newer code into second upstream, and the older one is running into first upstream, and after a TTL, the first one is killed, so that it has processed the queue that was pending with it before the switch, and none of the requests gets discarded, and you have a 0-time deployment. For monitoring, we use New Relic. New Relic can do most of the things that StatsD can do, but there are certain data, but New Relic is a paid component and StatsD is free, and there are certain data which we don't want to send to New Relic because it is public at New Relic send, though it's account based, but New Relic can see the data that you're sending. So we have real-time alerts on policy violations, on performance alerts, if your time threshold crosses any limit, and we have custom matrices as well. So custom matrix means if you have certain benchmark, which is not related to performance of your app, which is not related to errors in your app, but there is a certain business metric which you want to measure. Let's say transactions happening per minute. So there is an error, measuring that is one thing, but due to an error, there is certain things are cascading and front user is facing a problem, and that affects the business number. Those are the custom matrices. So for the application errors and performance matrices, you don't need to push anything to New Relic. The New Relic Python agent will work by itself. But for custom matrices, you have to intentionally push the custom matrix. So this is an example of a custom matrix. So we have a promo code called Go Karde, which gives discounts to the user. So if there is a problem in the promo code or the transaction engine, this number will fall low, and we'll get an alert immediately that there's a certain problem with the business. That's it. Any questions that you have? Yeah. Mhm. No, they are spawned on. So upstream has two things, active and backup. So active one is the one which is serving everything. Backup will be used when active is down. Okay, and in the second upstream, backup and active are reversed. Okay, so your code, current UWG workers are serving to this upstream. When next code deploys, it changes the port. It will use the backup of this and the active of this because these two are same things, right? And then after a TTL, this will be get killed and it will switch to backup, and backup is now the current active.
But that means there was space, enough space available for the two.
No, at for certain period, both active and backup are running.
Okay.
Yeah, and once active, so we have a UWGI hierarchy time of 80 seconds. In 80 seconds, we usually so there is a queue. It will take maximum of 80 seconds to complete. So there is a 80-second period for which both active and backup are running. It will complete. So for example, if I take a single process and if I do a graceful restart, the things that were waiting will wait for a lot of time because a graceful restart waits for the process restart and then the queue is served. But in this setup, both the active and passive thing are running, both the processes. It gets completed after a overlap of 80 seconds, the passive one gets killed. And in the next release, again they get reverted, active, passive, active, passive. Got it. You can come to our booth, I'll explain you in detail. I'll show you the production config if you want to.
So you were talking about Memcache and Redis actually, right?
Yeah.
So did you notice any point of inflection at which you decided that, okay, at this point of time,
Yeah.
Memcache is now behaving as not a supportive behavior actually?
Yeah, sure. So,
Any numbers actually or something?
yeah, so first problem was fragmentation. So we were wasting a lot of RAM. Keys were getting evicted, but RAM was not being used. That was one problem, but that's not the primary problem. You can, stay with some of the RAM being wasted, not an issue. But the second big problem was, so Voyager serves a lot of small payloads, but sometimes serves a lot of big payloads as well. And it crosses 1 MB very easily, even on gzipping. So what we had to do is we had to change the basic configuration of basic slab size of Memcache from 1 MB to let's say 5 MB. And even on 5 MB, you are not sure that some of your payloads will be within the limit 5 MB or they will cross 5 MB. So that's one thing to worry about. You are always worrying about your payloads, what the max size they are. But you can't blindly increase the Memcache config to say 10 MB because of the slabbing thing. So one slab will be created of 1.25. So the more you increase the basic slab size, the more the RAM will start getting wasted. And second thing was, when in 2-3 years back, Redis did not have cluster support, Memcache had. So that was the biggest advantage Memcache had. But once Redis cluster came in, so Memcache is like dinosaur compared to Redis nowadays. Very old. And if you want, I can forward you a discussion which I had with Anit Rez, the writer of Redis. That will be insightful to you.
So you were using Mongo
Yeah.
for the graph thing, right?
Yes.
Now, you are also searching based on the approximate match of the words
Yes.
and also geospatial
Yes.
searching.
Yes.
I just want to understand how are you doing it in Mongo?
Okay.
The second thing is basically, would it mean that all of your data in all of the Mongo data would have to be in RAM to make it actually fast, right?
Okay. I'll cover up both the questions. So this is the graph. So this is one directional graph which stores the geographical information in Mongo, and the bottom nodes will have all the parent information and the tagging attributes as well. And there is another graph which is a meta node graph. So Al-Sur Lake is a geographical entity, it exists. Indira Gandhi International Airport is a geographical entity, it exists. But Indigo Airlines is not a geographical entity, or Shatabdi train is not a geographical entity. So there is a graph for meta nodes. And how genodes connect within themselves is hierarchical, and how meta nodes connect to these nodes is, random graph. Anything can be connected and made a relation with anything. So this is being used for APIs, for if you see any hotels page or any flights page, but the search part is driven through Solar. So what we do is we aggregate content from this, and push into solar. Earlier we tried to use Mongo connector as a layer between Mongo and solar, but that doesn't work very well. Now we use PY solar and its REST APIs to aggregate content, score based on the things that we know. So we know Bangalore has maybe 780 hotels, and other city, let's say Bangkok has 2,000 hotels, and let's say user is searching from India. So we know Bangkok is a child of, Bangalore is a child of India, and Bangkok is an international city. So his interest might be more in Bangalore. So we push aggregated scores and the textual data that we want to search along with the geographical data into Solar and search the fuzzy thing, the spelling mismatches that you are talking about, or the boosting you are talking about happens in the Solar layer. And your second question was?
The second question was regarding all the data being in memory, right? In your Solar,
Yeah.
you would have to have huge memory sizes, huge machines with huge memory sizes, right? I mean, it would be very hard to, considering that you are doing the scoring part at the runtime, unless.
No. Scoring part is not being done at the runtime. So we are pushing aggregated scores into Solar, and Solar just uses a simple boosting formula to result your scores based on that.
And what would be the source of truth for the data? I mean, would this graph be, I'm assuming this graph would be the source of truth of
Yes. This graph along with other attributes. So this is a base core graph, and then this graph has metadata attached with every node.
Right, and how will you flow the data? I mean, just wondering, how do you flow the data from the source of truth, which I'm assuming the MongoB, to the Solar? I mean, how would that pipeline work?
Yeah, so we connect through PY Mongo to our scheduled tasks. So once we connect to Mongo, we know the target set for which we want to create our search. Take example of flights. We'll fetch nodes of all the flights or airports that we have. Then we'll start doing some aggregations. So how many hotels does this city have? Or let's say you type DEL. So there could be an airport Deloitte and there could be an airport Delhi. And Delhi has a traffic of let's say 1 million flights a day, and Deloitte has a traffic of 10,000 flights a day. So if somebody types DEL, Delhi should come on top. Or let's say if somebody is typing GOA, so an Indian user would assume that Goa should come on top, but GOA is also iota of an airport called Genoa. It should not come on top. So number of hotels, traffic, our traffic too, we also monitor how much traffic is coming to our entities, the past behavior of airports. So which sectors are booked more, we fetch that through our big data systems and plug it into this system.
I was actually wondering on the sense of data going to Solar. So Solar
Yeah,
there.
so you have
What are
Mongo
the change
documents.
events? What
Yeah.
are change events based on? So for example, there will be some change events, right? Change in, let's say, description of Delhi, a change in description something.
Yes.
change in the
So
traffic.
you are talking about whether it's real time or it's scheduled.
Yes, and how does it even flow? I mean, is there a messaging system which drives the change?
No, it's not a message system. So these things don't change very randomly, right? So we are not Flipkart or e-commerce, so that a vendor has uploaded something and it should appear on the selling system 5 minutes later. Delhi is going to stay Delhi for a lot of time. Airport name might change, hotel name might change, but if it's there for 2 hours, it's not painful for anyone. So once you have aggregate data into Mongo, you create an aggregated Mongo collection and push this collection one-to-one into Solar, exactly as it is, based on the Solar schema that you have. So for certain fields you have n-grams, and for certain fields like IATA you will do plain string matching.
Okay.
Does that answer your question?
Hi. So you mentioned that you ported some pieces of your code from Python G-Event to Golang, right?
Yeah.
So what was the reason and how
Okay.
was your experience?
Yeah. So reason was not flame wars that we'll do this and not do that. It was just that Golang was primarily written with concurrency in mind, and in Python plus G-Event you have to do a lot of monkey patching, right? Because it's not inherently inbuilt into every application that they will yield, especially the ones which work in C. So we decided to give Golang a go, plus its compiled language. We did some benchmarking. Python being interpreted was always slower than Go. So we just introduced in our stack, not for all components, but the components which need to yield something. So I'll give you flights example. There is a system called Thor, which runs on Golang. What it has to do is it has to fetch flights information from multiple providers, and some of them can be slow, some of them can time out, but the user can't wait for 15 seconds for his flight results. So all of the coroutines yield and fetch data, then dedupe it on real time and then serve it. And we are doing good with Go and as well as Python. Yeah.
So the basic thing is, as per my experience, Python serves well as long as Python G events serve well as long as there are multiple sources. I mean, as long as I/O is the problem.
Yes, exactly.
The only place where I have found problems is one of which you mentioned is basically when you are yielding from the C
Yes.
from the C API, something which is written in C API, or the other thing is basically when you are actually CPU heavy.
Yes.
When you are CPU heavy, events can't do anything.
Yes.
But the case which you are mentioning actually kind of doesn't look like any of them. Like
Yeah, that's what I said. It wasn't a switch that this is not serving us anything. That's why we introduced ourselves. We wanted to test a component and introduce in our stack, and both of them are doing fine. So the Python plus G event thing has not been shadowed completely. It also serves, our legacy Android applications.
But you definitely gained some performance. So did you go back and see why that? क्योंकि the point is considering. See, there
Yeah,
shouldn't
yeah.
have
So there
been.
were performance benefits, but since we wrote the new things from scratch, so those changes cannot be attributed just to Go, because we did a lot of database optimizations, library optimizations, connection poolings and all those things. So if you compare apple to apples, that was not an apple to apple change.
Okay.
So I can't compare actually.
Sure.
I have a question. So,
Yeah.
like, for querying MongoDB, so are you using any standard libraries like PyMongo or your?
So we are using PyMongo, but PyMongo is not singleton. So we are using custom wrappers written over PyMongo. So you can go to my GitHub and have a look. So multiple calls to PyMongo will use the same connection pool. So PyMongo once connected creates a connection pool, right? But if you use it in different methods, it might create different connection pools. So we use a singleton class, which does all of the connection management and all.
And also you have mentioned that you have emulated Mongo to have like a graph, like
Yes.
graph DB structure.
Yes.
So can you share some more points on that? How
Yeah, so it's a directional graph for geonodes, for geographical nodes. For meta nodes, it is anywhere to anywhere graph. So if I take Neo4j or Titan, for example, what they support is very good directional querying. So I can go node from, let's say, if we talk about family, I can go from grandfather to his son, to his son, to his brother in single query. Who is the brother of grandchild of Mr. X? So Cypher, suppose this query is very fast, but for Mongo, it's not optimized. So what we do is for each node, for the grandchild, we'll store parent, his parent and grandfather. For parent, we'll store grandfather. So each node has all the information about all the hierarchy.
So it's a bidirectional graph, like, right?
No, it's unidirectional. So India won't have information of the child, but Ulsur Lake will have information about India.
Okay, okay.
Got it? So if you want to see, and each parent type is also stored in the parent info. So if you want to know country of Ulsur, you'll get India. If you want to know state of Ulsur, you'll get Karnataka. And if you want to know area of Ulsur, Ulsur Lake, you'll get Ulsur. And this hierarchy differs from area to area. In India, you have states. In England, you might have counties. And Delhi is a special case, which is a state as well as a union territory as well as a city. So we deal with that kind of cases as well.
So you have written wrappers over Mongo, right?
Yes.
So is it open source or?
The Python Mongo wrapper is open source. You can check it on GitHub, but this data is not open source because it is a combination of loads of aggregated data that we do, and plus it
Fine.
contains our proprietary data, our hotel list as well.
Thank you.
Yes, it is, but in a very optimized way, using integers. Yeah. You mean to update the information? Yes. So we do a serialized update if any node is introduced, but it can inherit a lot of things. So let's say you want to add a new lake here, which is called, let's say, Nainital Lake, which is assumed in Bangalore. But you won't have to traverse anything. You will know that it is present in Ulsur area, and Ulsur already has the information of all the hierarchy. So you just replicate the information of Ulsur, and just that's done.
Yeah, you mentioned that you do the scoring pre-processing while transferring from Mongo to Solar.
Yeah.
So
First, no. First we do all the scoring, store it in Mongo temporary collections, then transfer document by document into Solar.
So this means that it is generalized for all the users. Your scoring pattern is generalized for all the users.
Yes,
Yeah,
yes.
not-
So
it's not user
yeah. So we do a little bit of user-based filtering, but that's primarily based on location. So if you go to Thailand, if you type BN, you'll see Bangkok at top. But if you are in India and typing, you'll see Bangalore on top. So it's a weightage of location plus the aggregate score that the place has.
So have you considered doing user-based in future? Like because like user customization is becoming the most
Yes,
important
yes,
thing
yes, but
nowadays,
it
and
would be over the already fetched data that we have. We won't be doing user-based querying a lot.
So my question is, solar documents are flat,
Yes,
right? And so they cannot show hierarchical relationship
exactly.
like this.
Yeah.
So are you doing some kind of entity recognition?
So I'll explain. So solar data is flat, right? So we store fields for, so solar has indexed documents and stored documents, right? So we, for the indexed part, we store the primary information that the user would be searching. Then there is a lot of other information which could be hidden. For example, spelling mistakes, or for example, aliases. So Varanasi is also known as Banaras, right? So we have meta fields for that field, which is flat. And there is other stored data which once you fetch the document, you want to know what was the score of this place. So that's stored in a simple JSON format, so that we don't have to make frequent changes to our Solar schema. So there's a JSON which gets passed on as text, and once retrieved, it gets deserialized.
And also my second question is, suppose in this graph, how will you query, suppose I want to find flights, I want to find hotels near Delhi, some place or some place.
Okay.
So how will you query in this graph? Because it is unidirectional. So
Yeah,
you
it is
cannot
unidirectional, but each of the nodes has lat long information. All the 10 million nodes have their lat long information, and MongoDB supports 2D sphere indexes, right? geospatial indexes. So for those kind of queries, you won't need the graph querying. You'll just do spatial query within a certain radius and filter based on the tagging that you have done for the node. So for Alsur, I'll do a geospatial querying for 5 kilometers, get the nodes which are of type Go Ibibo Hotel, and sort them according to the business ranks that I have.
So hi.
Hi.
So you guys use Redis for caching
Yes.
purpose. So while using Redis, I found out that the compatibility between Python data types and Redis data types is not good. So for a JSON that you have to save that is a pretty arbitrary JSON or some new payload that you have. So how do you convert, do the type conversion correctly? Because otherwise Redis will just save it as a string or something, and you have to always deserialize it or serialize it something.
Okay, can you give me an example?
Like you have a complete JSON of nodes, like
Okay, so
I've
you're
never checked it
talking
like-
about the things that cannot be serialized. Suppose a node which has a date time or a custom class in it, right?
Could be that, could be like you have a dictionary of n hierarchy, n level dictionary.
Mhm.
Now you need to write a parser so that you can convert each
Okay,
and
so
each and every key
yeah,
type
yeah.
of-
So that would be a choice between the space optimization that you want to do and the type of querying that you want to do in Redis. So if you want to do nested things, you'll obviously use Redis hashes, right? But if you have a smaller payload, you can just pickle or JSON dumps if it doesn't work. If it's not serializable in JSON, let's say it consumes custom classes or it contains date time which is not serializable, you'll use cpickle, convert it into a string or byte payload, and use it, store it as a key value store in Redis.
So my exact question was like, assume you have a particular JSON to cache.
Mhm.
Like you say that for this particular request, I have this API JSON
Yes.
that I will be sending. Now, how will you save this JSON in Redis, determining that the data type should be compatible, like the
Okay, so
Python integers should be integers in Redis also, like because they are Redis
So
data types are
JSON is
not
universal
different.
standard, right? So if I serve a JSON from Python and load it in PHP, the data types will convert it one to one, right? Integer will be integer, string would be a string, a list would be a list. But there are certain data types. So for example, if there is a date time, JSON can't,
That I get.
serialize JSON. It will have to be broken into, let's say, timestamp or some serialize or maybe a string. But if you were to load in PHP, the other native data types will get loaded as is, but the custom ones won't get loaded, right? So there's not a problem in Python when I'm serving JSON from Python, storing it in Redis in compressed format, reloading it, there's no change of data types.
So my question, I don't want it to be saved as a single string, as a single JSON. I want it to maintain hierarchy with using the Redis,
Yeah, so that you
Redis
can
data
do a
structures.
nested query, right?
Redis data structures. I want to use Redis data structures. I don't want to save it as a string.
Okay, so then you use hash, right? You'll have to change it though. Yeah.
That's what I'm saying. There's no automatic thing like I have.
Yeah, you'll have to write a wrapper for that.
custom
So if you want to,
function for
you have a
this payload.
Python dictionary, let's say 3 levels deep, and you want to be able to query Redis directly for the third level, you'll have to write a wrapper to convert that.
That will be a custom wrapper for that particular payload, I mean.
Yes, exactly.
So there's no way out that you can write a custom generic wrapper that could.
You can write generic wrapper for one, Python data type to the Redis data type.
But determining what to use when, then that would be a.
Yeah, that would be problematic and might be buggy as well. We can discuss this problem in detail. You can come to our booth. Any more questions?
Could you elaborate on your developer workflow at scale? And a follow-up question on that, you mentioned that you're using Jenkins
Yes.
as your CI. So why not Travis? And you're using all these modules together, so why not Docker?
Okay. So I'll take the first question. So our developer workflow is we use GitHub for our versioning. So once a developer merges into the master and a tag is created, the automated build system picks up the tags, run the series of tests that I mentioned. Then it goes to a pre-production environment. And because our data is very complex, we don't use a lot of mocking APIs or magic mocks because we can't replicate most of the scenarios. So our pre-production contains a near production ready snapshot of our database. And you run tests which read as well as write on that database. Once those tests finish, if they fail, that tag gets reverted from pre-production. If it succeeds, a production deployment downstream worker starts and which will deploy and with zero time in UWSJ configuration, as I mentioned. Second question you asked was about Docker, right? So we experimented with Docker, but we have not had the bandwidth to switch to Docker. So right now we have migrated to Amazon. So we have virtual environment based CentOS configuration, and we have pre-created optimized AMIs for our deployment. So we are using the AMIs. Docker is in plan, but not yet. And for the Docker thing that we had done was, so Docker was not a part of the build process. What we had done is, so we had created a Docker image of our stack that we had and hosted it on our private registry. So it was used to just to add another container. It won't be spawning a Docker container on the go as a part of the deployment thing.
Any more questions?
Both in Solar and Mongo. So
Yes.
So which one do you use, like Solar or Mongo? Or
Both.
Both.
Yeah, so Solar is primarily for the searching part, where you need spelling mismatches, where you need real-time ranking searches. But there are certain APIs which are not necessarily search. I want to show you hotels near a hotel, as in the recommendation system. So that will use the MongoDB special query. But if I were to boost your searches based on location, that will use the Solar part.
Any difference do you find, like if I search a same query on Solar and same on Mongo, so which one has a better results, or do they have the same result?
So for Solar, we don't use to find the nodes that lie within a range. We use it for boosting, ranking.
Okay.
But MongoDB use case is different. We used to find something within a distance, and MongoDB's to-this-fair index is really good, and with recent optimization, it is very fast as well.
Okay, thank you.
How do you handle failures when you're transporting data from Mongo to Solar?
Failures as in a REST document fails. Okay, so we'll just log it. That's it. We'll retry the failed documents, and there is never a idle document lying in Solar. So let's say Solar had 5 elements earlier. Now one of the hotel got closed. So ITC hotel is closed. Now we have 4 elements here. So if we do one-to-one update, these things will match. These will get updated, but this will stay orphan for a long time. So we have information what lies in Solar, what has been updated, then we truncate these nodes. And if something fails, we log and then we retry. No, it's scheduled task. So as I said, if something is missing, which is a smaller entity, doesn't make much of a difference. Plus, a lot of these things are pre-cached at the Akamai layer, then at the Varnish layer, then at the Redis caching layer. So you won't break anything which is user side. Yeah, it gets propagated, so it will appear. So you have to take a call on how much performance you want and how much, real time you want the things to be. So for 1 hour, the user may be able to find this hotel in the search thing. But once it gets on the landing page where you sell the hotel, those things are real time because you have to show the price real time, inventory real time. You'll see a sold out. So you can live with that.
Any more questions?
Okay, so we don't catch all the things. So because we have multiple layers, and then invalidation becomes a very difficult task. So Akamai does not support regex-based killing of the content that you have cached. It always kills a root. So let's say I'm caching /hotels APIs. You'll have to kill all the /hotels APIs to get Akamai cleared. Then comes varnish. Varnish banning is again not a very good functional thing. You have to keep passing the URLs that you want to ban. So we are using APIs which are very heavily loaded and change very rarely, maybe change very rarely in 2 days or 3 days. Only those ones we are caching on Akamai. So certain things which need an update, let's say within an hour or within half an hour, that get bypassed. So they are just directly served through Redis cache.
So basically static content gets crashed onto Akamai, whereas very live content gets
Yeah. So we have Akamai configurations based on the routes. So with different TTLs, most of the stuff gets cached on Akamai, but since searches are very dynamic, users might be typing, Delhi might be getting cached on Akamai very frequently, but somebody typing Agarwal Hotel might not be getting, it will bypass Akamai because it was never searched by other user in any location, so it will directly come to us.
So just for an idea, if you have 20 million of your raw data,
Mm-hmm.
what's the kind of total traffic?
So it would be approximately 1.6 times that of. For Ibibo application, it's 1.6 times. For Voyager, it might be a little bit higher.
Dhruv, a quick question. So basically, have you compared Solar with ELK stack?
Elasticsearch?
Yeah.
Yeah, so ELK we are using as a log aggregation framework. Yeah, when we decided on Solar, so Solar 4.0 was just released and Elasticsearch was present a little bit. So before Solar 4.0, there were lots of differences between Solar, and Solar was weaker. But as it was choice based on previous experience and the community support that you had. So we just made a choice with Solar, and our requirement for deep nested querying, which Elasticsearch provides, was not very strong. So we went ahead with Solar, and Solar has served us well.
Any more questions?
We have 3 more minutes. So.
In case you want to check out the GitHub repository of GoIbibo, that's over there, github.com/goibibo, and that's our carrier search page in case you want to note down. And I'm not present on Twitter, sadly, and this is my GitHub repo, and that's my Stack Overflow profile in case you want to connect or follow up sub discussions.
Thank you,
Thank
Dhruv.
you.
So we have lunch till 2, and after that we'll have lightning talks in Audi 1. So if you want to talk about anything for 5 minutes, you can go and register on the registration desk. And yeah, give your feedback on bit.ly/pycon-feedback. And yeah, and the open spaces is in lecture hall 3. And volunteers, be here by 2:45, so that let me check. Before 2:45 actually.